All right, so this is just a very surface explanation of what a matrix is. If you have more than one matrix, it's called a matrice. So there's more than one. It's not like the movie, but the movie does have something to do this. It's an array, a rectangular array of numbers. So a matrix is always determined or named by its dimensions, okay? So the dimensions of a matrix, the dimensions, or how it is named, is always in the order row by column. All right, so if you need a reminder, a row is what goes across. It's that horizontal line. This is a row. A column is, think of it like a column on a building, right? It's the vertical, it's the up and down. So matrix A, they're always named by a capital letter. So matrix A has the dimensions of 3 rows and 2 columns. So this is a 3 by 2 matrix. B is the same thing. This is on page 118 of your packet, last page. All right, matrix C, capital letter, it's 2 rows and 3 columns. So this is a 2 by 3. Okay, matrix D has 2 rows and 1 column. So this is a 2 by 1. So a matrix, one way to use this is to also solve for, it's called an augmented matrix. And an augmented matrix is designed to make it a little bit easier to solve a system of equations. So it's another way to solve for systems of equations. So on number 9, you have the system 5x minus 4y equals 9. And then the second equation is x minus 2y equals negative 3. So this is a system of equations. This is a y, not an x. So a matrix can be used to solve this very easily. So again, this is a very surface lesson on matrices. You don't have to know a whole lot more than this. But you should be able to take a system of equations, 2 equations, 2 unknowns, 3 equations, 3 unknowns, and come up with a matrix. So let's call this matrix N, just I don't know why. And the matrix is always designed based on the coefficients of your system of equations. So in the first row, we have 5, negative 4, and 9. In the second row, we have 1, because remember this is an assumed 1, negative 2, and negative 3. Now, what makes it augmented is there's a vertical line. This is where your equal sign is. And we're going to put in bars on either side, brackets on either side. The first column represents your x values. The second column represents your y values. And the third column represents the constants. And that's it. That's all that you need. If you have 3 equations with 3 unknowns, so let's say we have, so 3x minus 2y minus 3z equals negative 5, and you have x plus 2y plus 3z equals negative 3, and you have negative x plus 4y minus 6z equals negative 1. Okay, so this is an example where you have 3 equations, 3 unknowns. So in order to make a matrix for this, I'm going to call this matrix T. First row is 3, negative 2, negative 3, and negative 5. So x, y, z, and then the constant. Second row is 1, 2, 3, negative 3. And again, I'm getting this from the coefficients. Third row is negative 1, 4, negative 6, and negative 1. Put brackets around it. Put a vertical line where the equal sign is. And that is how you create a matrix based off of system of equations. All right? Now, if we go the other way, I could give you a matrix, and you have to come up with the system of equations. So for instance, if you had the matrix 3, -2, 4, vertical line 6, 9, 4, -1, 0, 6, -8, -3, 3. So now I'm giving you a matrix. You have to come up with a system of equations. Well, three unknowns. You have x values, y values, z values. There's your equal sign, and there's your constant. So it's actually quite easy. You go 3x minus 2y plus 4z equals 6. Second row, 9x plus 4y minus 1z equals 0. Third row, 6x minus 8y minus 3z equals 3. And that is your three equations, 3 unknowns. That is your system of equations. Now, we are not going to ask you to solve these, but you do need to know how to go from a matrix to a system of equations and a system of equations back to a matrix.